In the world of cryptocurrencies, consensus mechanisms play a vital role in ensuring the security and functionality of blockchain networks. One of the most popular consensus mechanisms is proof of stake, POS. This mechanism has gained significant attention due to its energy efficiency and scalability when compared to its predecessor, proof of work, POW. In this guide, we will explain what POS is, how it works, and its benefits in a way that's easy to understand even for beginners. What is consensus mechanism? A consensus mechanism is the foundation upon which blockchain networks operate. It ensures that all participants in the network agree on the validity of transactions and the order in which they are added to the blockchain. Think of it as a way for a large group of people, who may not trust each other, to reach an agreement on a shared ledger without the need for a central authority. Proof of stake, POS, is one such consensus mechanism, and it is a significant departure from the energy-intensive POW used by Bitcoin. So let's dive into the world of POS and see how it works. At its core, POS is a consensus mechanism that determines the next validator or miner to create a new block in a blockchain. Validators are participants who create and validate new blocks of transactions. Unlike POW, where miners must solve complex mathematical puzzles to create new blocks, POS relies on a different principle: the amount of cryptocurrency tokens a participant is willing to stake as collateral. Here's how it works. Staking. In a POS network, participants, often called stakeholders, are required to stake a certain number of cryptocurrency tokens as collateral. This means they lock up a portion of their tokens in a wallet as proof of their commitment to the network. Block creation. Validators are chosen to create new blocks and validate transactions based on various factors, including the number of tokens they have staked. The more tokens you stake, the higher the chances of being selected as a validator. Verification. Once selected, validators create and validate new blocks by adding transactions to the blockchain. They are incentivized to do this correctly because their staked tokens are at risk. If they validate fraudulent transactions or act maliciously, they can lose their staked tokens. Consensus. Consensus is reached when the majority of validators agree on the validity of transactions and the order in which they are added to the blockchain. This agreement ensures that the network remains secure and that all participants have a shared, tamper-proof ledger. Rewards. Validators are rewarded for their work with transaction fees and newly created cryptocurrency tokens. The rewards are proportional to the number of tokens they have staked, providing an incentive to act honestly and maintain the network's integrity. Now that we understand how POS works, let's explore some of its key advantages. Energy efficiency. POS is significantly more energy efficient than POW. In POW, miners compete to solve complex mathematical puzzles, consuming vast amounts of computational power. POS, on the other hand, selects validators based on their token holdings, eliminating the need for energy-intensive mining. Scalability. POS is inherently more scalable than POW. As the network grows, POS can handle more transactions per second without a corresponding increase in energy consumption. This scalability is crucial for blockchain networks seeking to support a larger user base. Security. POS enhances network security by requiring validators to stake their own cryptocurrency tokens. This financial commitment aligns their interests with the network's integrity, as they stand to lose their collateral if they act maliciously. Reduced centralization. POW mining has become increasingly centralized, with large mining pools dominating the network. POS helps reduce centralization by distributing the power to create blocks based on token holdings, making it harder for a single entity to control the network. Environmental impact. POS is often praised for its minimal environmental impact. It doesn't rely on energy-intensive mining operations, which have drawn criticism for their carbon footprint. Challenges and concerns. While POS offers numerous advantages, it's not without its challenges and concerns. Wealth concentration. Critics argue that POS can lead to wealth concentration, as those with more tokens have a better chance of being selected as validators and earning rewards. This could create a barrier to entry for smaller participants. Nothing at stake problem. The nothing at stake problem is a theoretical vulnerability in POS where validators could potentially validate multiple, conflicting blocks without penalty. In practice, network design and mechanisms are in place to mitigate this issue. Long-term security. POS networks heavily rely on participants' economic interests to maintain security. If a significant portion of token holders becomes disinterested or loses faith in the network, security could be compromised. Initial distribution. The initial distribution of tokens in a POS network can be a critical factor in its success. If tokens are distributed unfairly or concentrated in the hands of a few, it can undermine the network's decentralization and trustworthiness. Proof of stake, POS, is a consensus mechanism that offers a more energy-efficient, scalable, and environmentally friendly alternative to proof of work, POW. It operates by selecting validators based on the amount of cryptocurrency tokens they are willing to stake as collateral, aligning their incentives with the network's security and integrity. While POS has garnered widespread attention and adoption, it's essential to recognize both its advantages and challenges. Wealth concentration, the nothing at stake problem, long-term security, and initial token distribution are all factors that can influence the success of a POS network. Overall, POS represents a significant step forward in the evolution of blockchain technology, addressing many of the concerns associated with POW. As blockchain continues to mature, POS is likely to play a prominent role in shaping the future of decentralized networks.